will be Geometry Lesson 4.1. Today we'll be discussing how do we classify triangles, and there's two ways we can classify them as by sides and by angles. First off, let's quickly discuss about what a triangle is. A triangle is formed by three segments joining three non-collinear. What we have to remember is collinear. Collinear are points that are on the same line. So when we are looking for non-collinear, we are looking for 3 points that are not on the same line. The reason being is if I have 3 points that are on the same line, I cannot draw a triangle through those 3 points because all my sides would lie on top of each other. So what we need is we need 3 points that are not on the same line, that are non-collinear. And then what we could do is we could connect those 3 points real easy with 3 segments, and each of those segments, when put together, would form a nice pretty triangle. Now we need to name the parts of a triangle. Now I have 3 different triangles right here, and we're going to look at how do we classify these guys. But right now let's just naming parts of the triangle. So I'm going to label these triangles. I'm going to label this A, this vertex B, and this vertex C. Now that's kind of an important word. The word vertex simply means where two sides meet. So two sides meet at a vertex right there. It's the point where two segments, two lines, two rays meet. We use the word vertex when we were talking about angles, and we had an angle here. Well, this was the vertex. It's the same concept here. It is a vertex. All right? So those are the vertex. Now if we were to name sides, each side is a segment, so I call this side segment AC. I could call this side segment AB. And then I could call the third side a segment CB or BC. Okay, so those are the different parts of the triangle. So we have our vertices, which are where our angles occur, and then we have each side. And we will specifically look. Some of you may know what shape this is right here. This shape right here is actually a right triangle, which is something we're going to speak about here in a minute. But we have different names for different parts of this guy. And if you notice in this guy we actually have two equal sides, which we'll name this by sides here in a minute as well. But we have different names for the sides of this guy. So these two guys are special guys that we're going to look more in depth at throughout this chapter. All right. Now this guy is just a basic triangle. We don't know if any sides are equal and anything about the angles. Okay, let's go to classify triangles by their sides. Okay, now when we say by sides, we're saying how many congruent sides do we have, and that's how we classify by sides. Okay, so if we're going to look at an equilateral triangle, what an equilateral triangle is? It is a triangle with 3 congruent sides. Okay, so if we look down here, I have a set of triangles right here. What triangle in this drawing looks like it has 3 congruent sides? Well, to me, it looks like this guy would be an equilateral triangle. Okay, now if we look at this guy, an isosceles triangle, one of my favorite math words, isosceles. If you ever need to spell it, pronounce it isosceles. It's actually pronounced isosceles, but that's an easy way to remember that there's an SC in there. An isosceles triangle is a triangle with, now I'm going to say at least 2 congruent sides. Okay, so what isosceles means is you have at least 2 congruent sides. So this guy over here actually could be considered classified an isosceles triangle because it has at least 2 congruent sides. In fact, it has 3 congruent sides, so it does have at least, but we go more specific with this guy and talk about having 3 congruent sides. Now, which one of these triangles left down here looks like it has 2 equal sides? Well, to me, this side and this side don't look equal in this triangle. These I'm not sure on, but if we look at this triangle, to me, this side and this side look equal. So this guy right here would be my isosceles triangle, where this side and this side are congruent. Now, what we're going to get into is we're going to get into some of the angles here in a little bit and look at some of the angles in here as well throughout the chapter and today. Now scalene, so here we have 3 equal sides, here we have 2 equal sides, so scalene is a triangle with no congruent sides. Okay, so it goes 3 equal sides equilateral, 2 congruent sides, at least 2 congruent sides isosceles. When we have no equal sides in a triangle, we call that scalene. Now this guy this guy has no equal sides, but if we look at this guy also has no equal sides, so both of those guys would be considered scalene. Now that is classifying triangles by sides. Okay, let's look at the next one. Now, if we classify them by sides, we can also classify them by angles. So what we need to remember now is our types of angles. So remember our angles. We have acute, which is less than 90. We have right, which is equal to 90. We have obtuse, which is greater than 90 but less than 180. Okay, and then we also have that straight angle. But can we have a straight angle in a triangle? If you think of that, could you make a triangle out of a straight angle? No, you couldn't. Okay, when we make those three angles, we need those angles, so we cannot have a 180 degree in there. So we don't need the straight angle. Okay. Now, what we are looking for is in this, we're looking for what type of angles do we have. All right. So now an equiangular triangle, to me that's kind of obvious that an equiangular triangle is a triangle with three congruent angles. Now that sounds very familiar, doesn't it? If we look down here, what triangle looks like we have three congruent angles? Well, that was this guy again. Now if you remember on this guy, we have three equal angles. Now I'm not sure if you know how many degrees are in a triangle. In a triangle there's actually 180 degrees, something we'll explore in the next couple days. That this is 180 degrees inside a triangle between this angle, this angle, and this angle. And we split that up equally among three angles, meaning all these angles are equal. They actually each have to be exactly 60 degrees. Okay, so that's an equiangular triangle. Now the thing about this is if it is equiangular, it is automatically equiangular or equilateral. So if it's equilateral, it's automatically equiangular. That goes for triangles and triangles alone. Okay. So let's go to equiangular triangle, equal angles, and also ends up being equal sides. An acute triangle then, an acute triangle is a triangle with three acute angles. Okay, so we'll have three acute angles. Now, if you remember, that means we will have three angles in that triangle that are less than 90. Now, if we look at this guy, I need to label some stuff in here. Put some angles in here, but if we look at these angles, this guy's a right angle. That's not acute. That's right. So that's not an acute triangle. To me, this guy right here looks like it is greater than 90. You know, 90 would be right about here. If we draw our little box in there, that doesn't quite meet it. So this is not acute. This guy right here has three acute angles. So this guy right here would be an example of an acute triangle. Now, I could throw some numbers in there, and if you want to, you could. This guy would be like 80. This guy would be like 40. Let's say this guy is like 60. And then this guy would have to be 40. Now remember what I said, there's 180 degrees in here, so 60 plus 40 is 100, 100 plus 80 is 180, so that's the way it would have to work out. We have 1, 2, 3 acute angles. Okay. Now a right triangle is pretty obvious. A right triangle is a triangle that has a right angle. Now if we think a little bit, can I actually put more, could I put more than one right angle in here? Well, if this is a right angle and this is a right angle, then this side is going to keep going like this. Well, that actually looks like theorem 3.2 from last chapter where these two guys would be parallel. So can I have two right triangles in a triangle? No, we can't. We can only have one. So a definition of a right triangle is a triangle with only one right angle. All you need is one. All you can have is one right angle. And these guys right here are very, very powerful. We're going to see them tons this year, do tons of work with right triangles. All right, now an obtuse triangle is a triangle with one and only one obtuse angle. Okay, because if we think about this, that would be this guy right here. This is obtuse. Now this was also isosceles, what we had in the last one, but this is obtuse right here. Because this angle right here would be greater than 90. This would be like a 100-degree angle, or 110-degree angle, something like that. If you think about it, if I'm trying to draw a triangle, and I make one obtuse angle here, and then I come over here and make another obtuse angle, Would these two sides ever meet to form a triangle? No. So we cannot do two obtuse triangles in a triangle. Obtuse angles in a triangle. Once we have one, it's obtuse. Okay, so that guy'd have to be obtuse, and these other two guys are going to have to be acute. Something less than 90. All right. So there we go. There's our 7 ways. We have 7 ways to classify. We have 3 ways to classify by sides. Equilateral, isosceles being 2 equal sides, scalene being 0 equal. So equilateral 3 equal, 2 equal, 0 equal. And the classifying by angles, we have 3 equal angles. Acute triangle, we have 3 acute angles. Right, you have 1 right. Obtuse, you have 1 obtuse. Okay, so there's our ways. Now again, this is one way, and this is another way. Okay, so let's go work on these guys and start classifying some triangles. If we look at number 1, the first thing we're going to do is classify it by sides. I think that's always actually, we'll classify it by angles. Okay, so remember our ways to classify by angles. Equilateral, equiangular, acute, right, obtuse. Okay, so let's go by angles first. So we look at this guy, what kind of angles do we have? We look at that, we got a right angle, so this is right. Okay, again, this is acute and acute, but it doesn't matter. Once we see a right or an obtuse angle, we know it's going to be a right or an obtuse. All right, then we look at our sides. How many equal sides do we have? Well, we have no equal sides, so if we have no equal sides, what kind of triangle is it by sides? Well, that makes it scalene. So this is a right scalene triangle. Next one, let's go by angles first. Again, look at our angles. That's acute, that's acute. This guy is greater than 90, that's obtuse, so this is obtuse. Okay, now let's go look at our sides. 6, 14, 10. No equal sides, so this is obtuse. Scale lean. Scalene is scale knee. Okay. Now let's go to the next guy. Number 3. Let's look at our angles. Look at our angles again. We have 45 acute, and a right angle, so this is a right. Now let's look at how many equal sides we have. We have 4, 5.7, and 4. We have 4 and 4. We have 2 equal sides, so this becomes a right. Let's check back. 2 equal sides is isosceles, so this would be right isosceles. Again, I always pronounce it isosceles to remind you that there is that C in there. Isosceles. Right? Now I'm going to jump over 4. I'll come back to it here in a second, but I'm going to go to number 5. Okay. Let's look at our angles. Again, we're going to classify by angles first. That's the way I normally do it. We go 45, 50, 85. Acute, acute, acute. There's no right. There's no obtuse. There's not all equal. So this guy would be acute. Now let's look at how many sides we have here that are equal. We have 9, 8, and 13. Do you have any sides that are equal? No. So this would be acute, scalene. All right. Number 6, number 6, number 6. Let's go by angles again. Let's count. Let's look what we have. 70, that's acute, acute, acute. All 3 of them are acute, so this would be an acute triangle. Let's look at our sides. We have 10, 10, and 6. How many equal sides do we have? Well, we have 2. So that makes this guy acute isosceles. Now remember, I pronounce that isosceles to help me spell it. All right, number 7, let's look. Dead giveaway right there. Boom. That's what kind of angle? Well, that's a right angle, so this would be right. And then we have 6, 8, 10, which would be scalene. Now, put this guy on here. 6, 8, 10 is a right triangle. Get used to seeing this guy. This is a very important right triangle that we are going to do over and over again. By the end of the year, you will just hate that guy. You see it so much. Let's go back to 4 and 5. So again, what we have on 4, let's look. We have acute, acute, acute. They're all acute, so this would be acute. Now let's compare how many sides we. Now I didn't give you side lengths, but I did have these hash marks on there. Remember what those tick marks means that this side is equal to this side. So I could have like a 10 and a 10 here, a 5 and a 5. It doesn't matter. I didn't know this length, so it doesn't matter. But we do know that we have 2 equal sides, so this would be acute isosceles. Right. Next one. Let's look at what we have. We have 60, 60, and 60. So if we look there, we have 3 acute angles, but they're all equal. They're all equal. So this is not an acute. This is an equiangular. Okay, and then we have 3 sides that are equal, which are 15, 15, and 15. Now I told you earlier that if you have an equiangular triangle, it is automatically equilateral. Now that goes vice versa too. If you have an equilateral triangle, if you know you have three equal sides, you know that each of those angles in there is going to be 60, 60, and 60. Okay? So remember, there's 180 in here total. That's something we'll explore in the next couple days as well. All right? Let's go to these guys. We're going to be doing tons of this here when we get into section 4.4. It says identify the side that is opposite of the given angles in the drawing. Okay? So here's angle A. That's what we're looking at right here. Angle A. This angle right here. We want to name the side that is opposite. So what I'm going to do is I'm going to draw an arrow over there. Now I can't draw an arrow straight to this guy from this angle. I can't draw an arrow from this angle right here to the vertex over to this side, but what I can do is draw an arrow across that triangle to that side. So the segment that's opposite of angle A is segment BC. Right. Now let's look at B. Here's my vertex B. I can't draw it opposite to that guy. I can't draw it opposite to that guy. So what I got to do is I got to draw it opposite this guy. So the side that is opposite of angle B is segment AC Slater. Okay. Now if we look at angle C, what side is opposite of angle C? Now that's a right angle. This is a very important side right here. Opposite the right angle is side AB. Now some of you may know what that side opposite the right angle is called. That's called the hypotenuse. That's something we're going to explore in greater detail once we get to section 4.4. Let's look at number 10. We have, I'm going to go XYZ here. We have vertex X. What side is opposite that? The side that's opposite X would be ZY. Okay. The side that is opposite Y would be XZ. Now again, that could be ZX. It's irrelevant. Now notice what I'm doing, guys. If I'm taking this point, it's the other 2 points written as a segment. So if we're going Z, it's going to be XY, the other 2 points segment. All right. I think we can just do one more of those right here. If we look at angle D, side opposite would be RE. Now if you notice, this is an isosceles triangle right here because we have 2 equal sides. R would be DE. We actually have special names for these sides that are equal in that guy that we're going to talk about later. E would be DR. Right? Same thing over here. H would be RE or ER. E would be HR. It's just the other 2 guys. And then R would be HE. Again, get used to me drawing arrows across a triangle like that because I'm going to do that a lot throughout this chapter. Alright, so that is lesson 4.1 from geometry. What you can do now is flip over the worksheet and your homework would be lesson master 4.1b. Thank you. Good luck. If you have any questions, make sure you come in and see me in seminar.